The path of a place kick football can be modeled by the function y equals negative 0.026x times the quantity of x minus 46, where x is the horizontal distance in yards, kind of like our bridge problem again, and y is the corresponding height in yards. How far is the football kicked? And what is the maximum height of the football? So we have two things we have to find. Again, because I see I have a negative a value, mentally, what's happening in my head is, x is again this horizontal distance that our football is going to travel. Y is the vertical distance that the football is going to travel. And I in my head see this football, starting maybe at the origin and stopping somewhere out here, which is one of the questions we have. The other question we have is, well, how high up is this football going to get to go? What is this max height? It's important in Honors Algebra 2 to try to be fast, and I think a lot of you are starting to really get the hang of that. Part of being fast is to try your best to work with the equation in the form that it's in. So when I saw this equation, I quickly noticed that this is basically intercept form with a little tweak. Do you see here how we have this negative 0.026x? Well, this x right here could easily be put inside a quantity, and x is just the same as x minus 0. So right away, I can see what my intercepts are. My first intercept, and again, just to write the form, if you're like, what are you talking about intercept form? Intercept form goes y equals a times the quantity of x minus p times the quantity of x minus q. So do you see what I see here? I have one intercept at 0 and another intercept at 46. So right away, I know that point is 0. Well, no shocker there. And then this other intercept out here is actually at 46 feet. So that first question is answered. How far is the football kicked? Well, if it started at 0 feet and stopped at 46 feet, the distance it traveled across was 46 feet. So there's not even a ton of work to show for that because I just used my intercepts. So, the distance between 46 and 0 is just 46 feet. So that answers that question there. To get the maximum height, and we could just say our x-intercepts, those are 0, 0, and 0, 46. I totally wrote that backwards. So sorry. Try that again. 46, 0. I was already fast forwarding to y in my brain. Okay, so the other part of this is that I have to figure out how high the football goes. So how high up there is that? Remember to find the vertex when it's in intercept form. We have to first find that axis of symmetry. And that axis of symmetry, that formula is x equals p plus q over 2. So I'm going to take my intercepts of 0 and 46, plug it in. We get 46 over 2. So that's 23 feet, which makes sense because, well, hey, halfway to 46 has to be 23 feet. But that's not how high the ball went. That's just the halfway point for my parabola there. To figure out how high the ball goes, well, now I have to take this 23 feet and plug it in for x in my equation. So I'll take a second and do that. I'm going to go ahead and open up all the x's in my equation first. And wherever I see a blank there, I'm just going to go ahead and throw in my 23. And then I would go ahead and do my order of operations, and it turns out we get about 13.754 yards. So that is how high the ball gets kicked in the air. This is, 13.754 yards up. It's pretty high up there. So practically speaking, these answers make sense to me. So to answer the question in sentence form, how far is the football kicked? The football is kicked a horizontal distance of 23 feet and reaches a maximum height of 13.754 yards. Next up, we're going to go ahead and show you again how to get this on your calculator. So I went ahead and I entered the equation into my graphing calculator. But before I pressed graph, I thought practically, okay, like I'm kicking a football. It's giving me some numbers in the problem that are going to give me a clue. What are some practical values of x and y to fit my window? So then I hit window. And when I think about x, I was thinking about the horizontal distance that the football traveled. Well, if looking at the equation let me know that 46 was going to be where it kind of landed on the ground, I just picked 50 as an x max. So the football is going to start at 0 but land on the ground at an x value of 46, so I just went a little higher. And then I scaled that by 5 because 5 is a factor of the difference between my max and my min. Then I was like, okay, well, if it goes 50 yards out, I guess hypothetically it could maybe go 50 yards up. That's quite up there, but I was like, sure, why not? Again, arbitrary playing around with the numbers, just something that kind of, makes a little bit of sense within the problem. So I went from 0 to 50, and then a factor of the difference between the max and the min is 10. And then I did get this nice parabola when I pressed graph. To verify our max, we press second calc. You go down to option 4, and I got to go to the left of that 23 and to the right of that 23. And then I press enter again, and I do get that 13.754 as the max height. So that sort of graphically verifies the fact that that's the point where our football reaches its highest point. So that is how you can verify your answer.